I wrote it down. Obama was elected. He chose Vivek Kundra as federal CIO. One of Vivek Kundra's very first acts was to get the federal CIOs together and say, let's do cloud computing. That group ended up adopting my definition. The definition started getting adopted by the Cloud Security Alliance. The DMTF got interested in it. And eventually, industry, before I'd even officially published it, industry took the definition to ANSI and ISO for standardization. So we're going to talk about that definition. I no longer control it. The industry took it, it's in standards bodies, but at least I did publish it, and I'm updating that publication fairly soon. Along with that story is that last May, I had the opportunity, which happens to me quite regularly, of changing my career completely. And so I changed from doing cloud computing, which I've actually not done since last May, to take that into account, to continuous monitoring. Trying to figure out how do you do continuous monitoring for cloud. But I gave up because I figured I don't even know how to do continuous monitoring by itself, so let's figure that out first. And then we're going to talk about both and then try to tie them together and see how they fit. So I don't have much time. I'm going to spend to 1:30 on cloud maybe. Let's see. So here's proof it's not vaporware. There's the publication. First draft in February. And the links at the bottom. And you'll turn to it afterwards since we have time. Here's the short summary of the definition. The definition is about 2 pages long. The one slide I'll read to you. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Notice that I didn't mention the word security in here, did I? It's because it's not definitional. Clouds can be insecure. But why did I do this anyway? Why do we care? I've heard the word cloud mentioned many times at this event, and I believe that the majority of those times that it's been mentioned, it has not been referenced in alignment, conformance with its definition. So why do we care? Why can't we just all talk about cloud however we want to? The answer is we need to focus people on the capabilities and architectures that will truly deliver the promises of cloud computing. If we don't, somebody's going to say they're doing cloud, they might give us a cheap price, but in the long run, their architecture, their implementation will not support the vision that we really have for cloud computing. So we go back to the definition. And the definition, really, if I was to abstract it, I'd talk about the customer giving up control in order to harness perceived benefits. And so notice I didn't mention security because it's not definitional. I didn't mention virtualization. Am I an idiot? What is going on here? The answer is no, you don't even have to have virtualization to do cloud. Do I recommend you use virtualization? Well, depending on the cloud model, yes, very strongly. But what are these benefits? Well, I believe, and evidently others believe, since they took it to ANSI and ISO, that these 5 essential characteristics will give you the benefits of cost savings, rapid procurement, energy savings, green savings, all the things we talked about. And we don't have much time, so I'm really not going to go into them quickly. But certainly empowering the business customer. That the business customer being able to on-demand do what they want. Not go to the CIO shop and talk to somebody and create some procurement, but to actually just get it. From anywhere, sort of with anything, is the next one. The resource pooling causes lots of interest. Basically, in short, we want to increase our server utilization. A typical standard server utilization around 15%. I've heard 10, I've heard 5. You know, we ideally want to get that up to about 80%. And with this resource pooling, there's location independence. You may know what country your data is in, you may know what state your data is in, you may know what data center your data is in. But do you really need to know, or should you even care, exactly what computer is running your process? Or exactly what storage device is storing your data? No, you really don't. Combined tier elements of multi-tenancy. I've never seen this in the literature, but I divide it up into 2 types. Data multi-tenancy, processing multi-tenancy. So multiple people's processes running on the same hardware versus multiple people's data existing on the same hardware. And so keep that in mind. We'll discuss that in a second. I'm going fast on purpose. I apologize. I have no time. Cloud presents an element of homogeneity, whether actual homogeneity or an abstraction of it, which is important for the continuous monitoring discussion later on. But it also provides a lot of efficiencies, and that's how you get a lot of the cost savings. The rapid elasticity, you can scale out, you can scale back in, you use the resources you need, and no more. And lastly, measured service. You're measuring the customer usage, you have a feedback loop, you're optimizing the customer usage through either charging them or some other mechanism. So we have some service models here. Hopefully you all know what these are. Software as a service, a software app, you connect over the internet, it's a dynamic web page, pretty simple. Infrastructure as a service, typically virtual machine rental is where we get into this. Platform as a service, where you're creating an application and then sending it off to be run in the cloud. This is great for commodity applications. This is great for transitioning over your existing data center. You want to evolve your data center into a cloud. This is great. Actually, if you're using virtualization, you are turning into a cloud. The same virtualization providers where you're virtualizing your data, your processing, your storage, your network, they're starting to give you these essential characteristics. And the more they give you, the cloudier you're becoming. So I argue your data centers are becoming cloudy. And that is a good thing, but that's also a security issue. I believe platform as a service is like that future sweet spot, if we ever get to it. Sweet spot between giving up control and having control. Between being able to write your own apps or use others' apps on a particular cloud. But it remains to be seen for sure. Which is better? Now they all have their uses. Which is more secure? Well, remember that multi-tenancy discussion. We've got processing multi-tenancy here. We only have data multi-tenancy here. You can't run your own process on a software as a service. So is it more secure? Maybe. There are definitely greater threat factors here. Processes can attack processes. Data does not natively attack data. It has to be executed. However, I've seen some very secure implementations. Software as a service typically has a nice, very layered approach, defense in depth. It can be constructed very, very securely. That said, if this is a public software as a service, the problem is anybody can sign up for that service. So the surface area of attack is huge. It's not just a login screen. They can be an authorized user. They can touch every knob and widget. The attack surface is huge. So there are security concerns there. But jump down here, especially down here, you're typically using virtualization. Now, we all use virtualization now, but we're using virtualization in a different way. For you to use a cloud, you have to assume that the other customers are malicious. You have to assume that.